Hello everyone, hope you guys are doing well. In this video series, I'm gonna go through the stoichiometry. We have started this topic with you guys, but I'm gonna finish off and go over some of the stuff second time. So in the beginning, we're talking about the balancing. We already went through it. I also gave you some worksheets that you had to do, but uh, I'm just gonna go over it again as I mentioned. So on the left side, in the chemical reactions, we have reactants, and on the right side we have the products. So reactants are reacting together and producing us the products. Okay, so in this reaction I have methane, which we will cover in 11th grade what kind of chemical it is, but we have a combustion reaction given to us, and the product gives out the CO2 and the water. As you see over here, they have balanced all the elements uh, from with left side and right side. So let's count the carbon, hydrogen and oxygen on the left side. So I have one carbon, and then I have four hydrogens and four oxygen. And on the right side I have one carbon, and then I have here 2 times 2 gives you 4, and then I got 2 oxygen here, and then there's 1 oxygen. 2 times 1 is 2, so 2 plus 2 will give me again a 4 oxygen. So this chemical reaction is fully balanced. But I have here the ones that are not balanced, so we're gonna do it together. So I got here iron and I got here oxygen, and so I got 3 of the iron, so I'm gonna put 3 in here, and then I got 4 oxygens. You see, I can't change indexes, okay? I can't do that. The only thing I can do is to add coefficients in front of them. So over here, since I got 4 oxygen, I will add 2 in here, and 2 times 2 gives you 4. So 3 irons and 4 oxygens, which is the same as in here. So this reaction is balanced. I'll do one more in the bottom for this one. So I got 3 carbons, right? So I put 3 in here, so I balance the carbons with left side and right side. I got 8 hydrogens on the left side. I got only 2, so I put 4 in here, and I balanced the hydrogens and carbon. The only thing I've left is oxygen. I got 2 oxygen on the left side, but I have 2 times 3, which is 6 oxygens, and 4 times 1, which gives you together 10 oxygens. So in order to balance it with the left side, I will multiply it by 5. So altogether now everything is balanced. Using these chemical reactions, we're going to do some calculations. So know that you have to know how to perform balancing. If you look into the periodic table and check out the carbon on the periodic table, you will see that carbon has an atomic number of 6 and atomic mass of 12. This atomic mass was represented with 12 AMU, atomic mass unit. So if I have one carbon atom, I have 12 atomic mass units. But if I grab 6.02 times 10 to the power of 23 carbon atoms, now in here I have 12 grams. And you know this number, I said that it is 1 mole, right? So what does that represent is that 12 carbon for 1 mole has 12 gram of mass. That means that 12 gram is molar mass of carbon. And we write it in terms of like this, 12 gram per mole. And this is going to be molar mass of carbon. Okay? So I want you to really remember this very well. So 12 gram per mole is the molar mass of carbon. Now we continue with what is given to us. So you know that Avogadro has this number, and we say that anything, any particles like this many atoms gives you 12 grams of carbon, which you can see from the periodic table. So before you used to just say that, okay, atomic mass of carbon is 12, but this time when you look at the periodic table, you're going to say 12 is the molar mass of the carbon. Now, we're going to continue with the formulas. So there are many ways to find the moles. We can use proportion on all of them. But the main formula I'm going to write you here are these ones. So mole we're going to define as N. N is your mole number. Mole number. Now, let's say if you're given that 3.01 times 10 to the power of 3 atoms are given to you. You want to know how many moles is that. You want to know how many moles is that, okay? So the formula that I have here is equal to N divided by N, given number of particles, divided by Avogadro number. So Na is 6.02 times 10 to the power of 23, and N is anything that is given to you. In this case, we have this 3.01. So if you have this many atoms, so it will be 3.01 times 10 to the power of 23 divided by 6.02 10 to the power of 23, which gives you 0.5 mole. Okay, so this is one way of finding the mole. Now I'm going to show you how you can find it with the mass of a substance. Let's say you're given that your water H2O has 9 gram. Like it's given to you 9 gram of water, okay? And you need to find how many mole is that. How many mole is that? So in this case, you're going to be using this formula. N equals to mass divided by molar mass. So I'm going to write the units of this. So mass, we know that if it's given to us, it's going to be, so this is a given mass, given. And this is molar mass, molar mass. Molar mass has this units, gram per mole, okay? And then mass has the unit of gram. We know that if you do the math, gram multiplied by gram per mole, this is going to be how the division looks like. Gram cancel gram, and you have a mole. So as you see, the mole, this is how we get it in terms of units. So let's say we have the water. We need to find the molar mass of the water, right? So we're going to check out the periodic table. We will see that oxygen on the periodic table has 8 on top and 16 in the bottom. That means that oxygen has a molar mass of 16. So oxygen, mm, is going to be 16 gram per mole. And then we got 2 hydrogens, right? So we're going to check out the hydrogen molar mass, which is 1 gram per mole. But because the water is the molecule made out of hydrogen and oxygen, we are going to write molar mass of water like this. Because I have 2 hydrogens, it will be 2 of the molar mass of hydrogen plus 1 time molar mass of oxygen, which will be 2 plus 16, and it will be altogether 18 gram per mole. Okay, so now we have the molar mass of water, okay, which is 18 gram per mole, and I'm gonna use this formula over here, this formula to find the mole number. So this will be n divided by 9 gram divided by 18 gram per mole, and you're gonna be getting the answer of 0.5 mole. Okay, so this is another way of finding it, but you can just use the mole, to be honest, use the proportion. I'm gonna use a proportion way, so whichever way you like. I personally like using the formulas. So with proportion, the way you will do is that, because for 1 mole of water, you have 18 gram, and then 9 gram, for 9 gram you have x mole. So you do the math, 18x equal to 9, x would be 9 over 18, which would be 0.5 mole. This is way of finding with the proportion. Now there's the same thing, we could have done it here with the proportion. So you would say for 1 mole you have 6.0.2 times 10 to the power of 23, and then 3.01 10 to the power of 23. You don't know how many mole is that, so over here you do the same. X equals to 3.01 times 10 to the power of 23 over 6.02 times 10 to the power of 23. It gives you 0.5 mole. So we get the same answer. As you see here, we're getting the same answer, but in here I use the formula, but over here I use the proportion. Same thing, I use the formula and I used proportion here. Now there is another thing about the volume of the gases. So Avogadro, when he was doing a discovery, he found out in his experiment he had these balloons filled with different gases. I'm just gonna try to draw them in the same volume. So he had these different gases, helium, oxygen, and nitrogen in them. And then what he did find is that at the same temperature and pressure, they had same volume. That means that they had same amount of particles. So what he figured out is that at standard temperature and pressure, which is, I'm gonna tell you what is those. All gases of 1 mole have 22.4 liter of volume. So what does that mean? That if I had 1 mole of helium, 1 mole of oxygen, 1 mole of nitrogen in here, at temperature of 0 degrees Celsius and pressure of 1 bar, which is, this is standard temperature and pressure, STP. So at STP, 0 degrees and 1 bar, all 1 mole gases, they have 22.4 liters. They are all 22.4 liter in here. So now this is another way, and the formula for this is going to be N divided by V given divided by VSTP. So V given is going to be like this. Let's say you're given to you 11.2 liters of oxygen, and you want to know how many moles is that. Okay, you want to know how many moles is that. what you will say, okay, N divided by 11.2 liter divided by 22.4 liter, which is the STP volume, it will be 0.5 mole. Okay, or if you want to do with proportion, you do 1 mole equal to 22.4 liters, and then X mole would be 11.2 liters. And you do the math, it will be 11.2 liter divided by 22.4 liter, it'll be 0.5 mole. So both ways you arrive at the same conclusion. And regarding the mole, I know I sometimes write mole with E without the E. So in your case, it doesn't really matter. Just write whichever way you like, because one of us in English, the other one is in Azerbaijani. Okay, so now that we have learned 3 ways of finding it, so I'm gonna mark this formula 2, and then we have the proportion. Now we're gonna go over other questions and we'll see how you guys are good at it. So I'm gonna review this one again. So 1 mole of carbon has this many atoms and has this many 12 grams in it. 1 mole of oxygen has this many atoms and has 16 grams. Before I just move on, so let's say I have 1 mole of H2O molecule, right? Molecule. That means that I have 2 mole of hydrogen atoms, because as you see, I have 2 hydrogen atoms per 1 mole of water molecule, and I have 1 mole of oxygen atoms. So you could say that in 1 mole of water molecule, I have 3 moles of atoms. Okay, or you could say, you could use the Avogadro number. Let's say 6.02 times 10 to the power of 23 H2O molecules, and 3 times 6.02 times 10 to the power of 23 atoms. Okay, so just like this. Now, oxygen, finding the molar mass of oxygen. We know that oxygen has an atomic mass of 16, also molar mass of 16, because oxygen is made of 2 oxygen atoms. It'll be 32 gram per mole, the molar mass of it. Okay. For example, sucrose. Sucrose has this formula, C12H22O11. It is the main compound of the sugar. So in 1 mole of sucrose, if I want to find out the molar mass of it, in 1 mole I have 12 moles of carbon, 22 moles of hydrogen, and 11 moles of oxygen. What I do is I multiply their molar masses of each compound, each element, sorry. Carbon has 12, we talked about it. Hydrogen has 1 if you check the periodic table, and oxygen is 16. You multiply them and you add them, you get the molar mass of sucrose, which is, we write it like this, C12H22O11, like this, 342.3 gram per mole. Okay, so now it's asking us to find out the magnesium nitrate molar mass. I got here nitrogen, and then I got here oxygen. Because I have 3 oxygen, I multiply by 3, but I also have here outside, I have 2. So I need to multiply everything by 2, and this is the magnesium molar mass. You add them up, you get, this is the atomic mass. In terms of atomic mass units, the 1 molecule of magnesium nitrate. But when you have 1 mole of magnesium nitrate molecules, meaning having 6.02 times 10 to the power of 23 magnesium nitrate molecules, the mass of it is going to be 148.33 gram per mole. Okay, so now it is asking us what's the mass of 1.33 moles of titanium. If you check out the periodic table, you will find that the titanium has molar mass of 47.88 gram per mole. And I told you the formula of this is going to be N equal to M given divided by molar mass. Because it is asking us the mass of it, M would be N times molar mass, which will be 1.33 mole multiplied by 47.88 gram per mole. So we know that mole cancel mole out, and then you get the answer of 63.7 gram. But you can also do the proportion here. You say 1 mole is 47.88 gram, 133, you don't know how many, and you find it. And then we move on. Now it's asking us how many sodium atoms are in this many moles of sodium. I told you the formula. We have N given over Na, which is Avogadro number. This is number of given particles, the N, capital N. So now it is asking us the capital N multiplied by Na. And you know that 0.12 is given to you, and Na it is 6.02 times 10 to the power of 23. And then from here you get the answer, which is 7.2 times 10 to the power of 22 sodium atoms. Or as I said, you can do the proportion. You say 1 mole is this many atoms, 0.12 is this many atoms, and then you do calculation. Now it is asking us how many moles of potassium are in this many atoms. It is asking us the mole number. And I told you the formula is N divided by N over Na. And then it is given us that 1.25 times 10 to the power of 21 divided by 6.02 times 10 to the power of 23, it'll be 0.02 moles. And then you can do the proportion again. 1 mole is this many, and this many particles is X moles, and then you can get the answer over here too. So now it is asking us in this question how many molecules are in 5 moles of water. So you can use the formula again. N equals to N divided Na. Now it is asking us the capital N, how many molecules, N multiplied by Na, and then you know that 5 is given to you times 6.02 times 10 to the power of 23, and it will be 3.01 times 10 to the power of 24 molecules. Or you can do a proportion, 1 to Avogadro number, 5 X moles, and then you get the answer. And then over here is asking us how many atoms are in 5 moles. Because we know that in 1 mole of H2O, we have 3 moles of atoms, right? Of atoms. So in 5 moles, there are 15 moles of water atoms. And you can do the proportion, or you can use the formula again, using the formula above. So over here, I'm just going to show the proportion. For 1 mole, you have 3 times Avogadro number, and for 5 moles, you don't know how many, and then you can get the number in the bottom. But this time we're going to move on into finding using the molar mass. We can go from particles to molar mass. So before we were using just particle number and getting the mole number, right? But now we're going to use the mole number to find the given mass. Okay? Because we know the molar mass, once you have the N and the mole number from this formula, you can use it to this formula and multiply by molar mass and can get the mass given to you. For example, it's asking you what is the mass, right? So now you're given the N, which is given to you. You know the Na. You can get the molar mass, which would be 2.55 times 10 to the power of 23 over 6.02 times 10 to the power of 23. And then you know this, and then you need to check out what is the molar mass of lead, which is 2077.2 gram per mole. And once you have the mole number, you know this, that N is M over molar mass, and then M would be N multiplied by N mm, right? And your M would be literally just your N is given to you, like if once you do the calculation, 10 to the power of 23 times 6.02 times 10 to the power of 23 multiplied by 207.2. This is your mm and this is your N. And then from here you can find that it'll be 87.8 gram. Or you can use proportion, because you know the molar mass of lead, 2.7, and it would be, because it is molar mass, it would equal this many particles, right? Avogadro number. And you're given that how many these particles would be at how many grams. And you can use the proportion and find the value. And we have the similar questions over here, but I'm gonna go over the gas one. So I told you that volume of any gas at STP would be 22.4 liter, but it is for 1 mole of that gas, 1 mole. So 1 mole would be 22.4 liter at STP for any gas. Let's continue with the question. So you're given to you is that 4.5 liter at STP, how many moles is that? So what you do is that you do either proportion, you say 1 mole is 22.4 and 4.4 is how many moles. You can get it, or you can use this formula, N equals to V given, or V divided by V STP, and it would be 4.5 divided by 22.4, and it would be 0.2 mole. So over here, what is the mass of 3.36 liter of ozone? So now look at this one. So because we're going to use this formula, we will find from V given, VSTP, we'll get the mole number. And then using that mole number, you can find the mass of this because you know the molar mass, right? Ozone has 3 oxygen in it. The molar mass of ozone would be 3 times 16, which is 48 gram per mole. Okay, so now you know the molar mass. You're given 3.36 liters. So you have V given, and then you have VSTP, which is 22.4, and you can find the mole number. And you know the molar mass, now you can find the M. So your N is 3.36 liter divided by 22.4 liter. And then you know that M equals to N multiplied by MM. And you can just plug in the numbers even without the calculation. 3.36 divided by 22.4 multiplied by molar mass of 48, and you can get the gram, 70.2 grams in here. Or you can just use the proportion again. We say that the molar mass is 48, right? Because it is for 1 mole, we know that it will be 22.4 liters. And 3.36 liter is given to you. You don't know how many grams. You do the proportion and you get the answer. We will do one more question on this. So it is asking us how many molecules of hydrogen gas occupied 11.2 liter STP at STP. So again, the formula N divided V over VSTP, 11.2 divided by 22.4 liter, it will be 0.5 mole. Okay, and then once you have this mole, you have the formula of N equal to N over Na, right? So N would be, because it is asking you this guy, the capital N, and you always have the Na value. It is given us. So N multiplied by Na, and this would be 0.5 multiplied 6.02 times 10 to the power of 23. It will be 3.01 10 to the power of multiplied by 10 to the power of 23 particles. Or you can use again the molar. You know that 1 mole is this many molecules, and it would be this many liters for 1 mole, right? So for this many liters, how many particles? You do the proportion and you get your answer. So as I told you, there are 2 ways to approach it. And now we're gonna be doing one more. Now it's asking how many hydrogen atoms. It's not telling us molecules. It's asking us how many hydrogen atoms, right? Over here you found how many molecules, right? 3.01 times 10 to the power of 23 molecules. In one molecule, hydrogen molecule, you have 2 hydrogen atoms. So altogether, if you do the logic, you need to just multiply this number by 2. It will be 6.02 times 10 to the power of 23. Or you can just start from the beginning. You can find the mole number and you can find and multiply everything by 2. Okay. So now, what is the molar mass? That is a good question too. We're gonna try to find the molar mass. So we're given 10 gram of unknown gas. Okay, so we're given the mass. Okay, we're given V to us too, and it's asking us the molar mass. We know that using volume VSTP, we can find the mole number. That is 1. So using this, so using V, because it's given, we know this, and we can get the mole. And then using the formula, we have M over molar mass. We are given to us the M, and once we find N from here, we can get the MM. Okay? So we can just write MM molar mass equals to M over N, right? This is one formula, the one that we will use in the end. And in the beginning, we have this one. So N equals to 1 liter divided 22.4 liters. This is your N. And then we're gonna just use M. M is given like this, 10 gram, divided by, this is gonna equal to mole, right? So that's why we will just gonna write little cancels out. We're gonna write in mole. N would be 1 over 22.4 mole. And we can just write like this, 22.4 mole. And this is gonna be equal 22.4 gram per mole, if you do the math of this. So the molar mass is gonna be looking like this. Or you can, as I said, do the proportion. You say 1 liter is 10 gram and 22.4 liter is this many gram, because 22.4 liter is 1 mole, right? So you will be able to find the molar mass of this, and it would be 224. Now in here, proportion seems like it made it easier to get it, but a lot of students tend to make a mistake specifically in this type of question, but it is up to you. You can either use both, it doesn't matter. As long as you got the right solution, we're gonna give you the points here. Okay, so as a conclusion, we have Avogadro number equals to this. The molar mass of any substance is the sum of atomic masses, such as oxygen. Oxygen has a molar mass of 16, but O2 from oxygen gas, we know that the molar mass of oxygen gas would be 2 times 16, which would be 33 gram per mole. This is gram per mole too. And the water, for example, we have hydrogen and oxygen, which will make it 18 gram per mole. And then at STP, 1 mole of any gas occupies 22.4 liter of volume. And STP temperature is 0 degrees Celsius and pressure is 1 bar or 760 millimeter mercury. This is the STP. Now, if you remember, we already talked about reaction. Now we're coming back and attaching everything we learned into the reactions. We got reactants and products. Let's say we're given a reaction to us, and I have the reaction of water decomposing, right? There is decomposition. First of all, even without balancing, I'm just going to write this. Let's say you're not given this to you. You've been just given this equation. You need to first of all do the balancing. So you have 2 hydrogens here, 2 hydrogens here. Okay, that seems okay. But oxygen, you got 1, and oxygen, you got 2. You can't change the index, so all you do is just multiply this by 2 to make the oxygens okay. And then you need to balance the hydrogens. You got 4 hydrogens here, 2 hydrogens here, and then you balance like this. Now everything is good. Okay? So we have this. Now it's asking us how many liters of hydrogen will be produced from 6.2 moles of water. So these coefficients are giving you ratios. So let's say if 2 moles of water decompose, it makes 2 moles of hydrogen H2 gas and 1 mole of oxygen gas. Because you see the ratio, for 2 moles of water, I got 2 moles of hydrogen and 1 mole of oxygen. So let's say if I had 1 mole of water decomposing, I would get 1 mole of hydrogen gas, and I would get 0.5 mole of oxygen gas. Okay, you just need to know this. We need to have the ratios. So now it is told that we got 6.2 moles of water. So if I have 6.2 going in here, I need to have 6.2 liters of hydrogen and 3.1 mole, 6.2 mole, and it's all molar ratios, okay? We're not messing with the liters, only moles. We need to convert everything into moles and then use these ratios and do our calculations. So 6.2 moles is giving me 6.2 moles of hydrogen. We know this. Now it is asking us how many liters is that. So we know that we have this formula, N equal to V over V STP, right? We're given the number of moles. We know the STP, we're just looking for the V, and this V equals to N multiplied V STP, and this would be 6.2 multiplied by 22.4, and this would give you the value of 138.88 liters. Or you can do the proportion. You say, for example, 1 mole of H2 is 22.4 liter, and then you get 6.2 mole H2, and you say X liter. You do the calculation and you get the X of 138.88. Okay, so either way works. They have shown it in here like this. For 2 moles, you got 2 times 24 liters, because this 2.24 is moles, right? For 2 mole, you get 2 mole, and then this many liters and this many moles. So you can do the proportion, whichever way works for you. I'm gonna do a couple more in here. So it is telling you how many grams of calcium oxide will be produced from combustion of 20 grams of calcium. So the combustion, it is given here. You will be told about the combustion, like we told you before, that combustion is only we have oxygen going in and the product gotta be CO2 plus H2O. But in this case, this is an exception. We're giving you calcium and it's getting into combustion with oxygen, and you get the product of calcium oxide. So you see the reaction is not given to you. You need to figure it out yourself. So now, first thing I did, I wrote the reaction. Second thing I do is the balance. Okay, so in the balance I check out the oxygen amount, so I put 2 in here, and then I see that okay, oxygen are balanced. Now I check the calcium. Okay, I got 2 on the right side and I make 2 on the left side. So now everything is balanced. And then over here it's asking me how many grams of calcium oxide will be produced from 20 grams of calcium. So 20 grams of calcium, you don't know how many mole is that. M calcium is given you as a 20 gram. Okay, so we're gonna go back and find, using the formula, we'll say okay, N equal to M over molar mass, and you check the molar mass of calcium. So this is calcium and calcium. You check the molar mass of calcium, it is 40, and this is 20 gram per mole, and then this is gonna be 0.5 mole. So now it is asking how many grams of this you will getting, right? Because you know that 2 moles gives you 2 moles back. So because this guy is going in 0.5 mole, you will be getting 0.5 mole of this. So now you have the molar amount of calcium oxide. This is, you found it. You can find the molar mass of calcium oxide, which is just the molar mass of calcium plus molar mass of oxygen. And this is 40 plus 16, it will be 56 gram per mole. Okay, and then you have the molar amount. What you do is that M equals to N multiplied by molar mass, the formula that we had, N divided M over mm. Okay, and then what you do is that 0.5 multiplied by 56, and you get 28 gram of calcium oxide. And this is the answer you have. Well, that wraps it up for me, and then you can do these questions yourself, and we can check back once I'm back to AG school. Thank you guys. Take care.